everybody, let's do a fun demonstration to see some of the differences between liquids and gases. One of the key differences between these two phases is the distance between molecules or atoms. In a liquid, the atoms or molecules of a substance tend to be relatively close together, while in a gas, these atoms and molecules are spread much farther apart. We're actually going to be able to see in this experiment how the distance between atoms in nitrogen compare when the nitrogen is in liquid versus when it's a gas. Behind me, I have a tank of liquid nitrogen. I'm going to put some of it in this cup. We're then going to take this cup and drop it into this trash bag and allow the liquid nitrogen to turn into its gaseous form. We're then going to measure the volume of liquid nitrogen in this cup and the volume of gaseous nitrogen in this trash bag. We're then going to be able to use this information to compare the distance between atoms in liquid nitrogen to the distance between atoms in the gaseous nitrogen. Now, nitrogen is non-toxic. It makes up about 70% of the Earth's atmosphere. However, liquid nitrogen is extremely cold, so we have to be careful because if it splashes on us, we could get burned. Here's what we're going to do. I'm going to dump this into the styrofoam cup and then mark the level of liquid nitrogen. We're then immediately going to put it into the trash bag. We'll worry about calculating how much liquid nitrogen was in here later. All right, here we go. All right, now we just wait for the liquid nitrogen to turn into a gas. Now, I know it may look like this nitrogen is leaking, but it's actually just condensation. Because the nitrogen is so cold and the bag is cold, water from the air is condensing onto this bag. Alright, I think the liquid nitrogen has mostly turned into a gas. So how are we going to figure out the volume of nitrogen in this bag? Well, this bag is a fairly irregular shape, so we're not going to be able to get a perfect readout. However, if you look at this bag from this side, this face looks sort of like a triangle. So if we can calculate the area of this triangle and multiply by the length of the bag, we should get a reasonably good estimate for its volume. My result is that the volume of this bag is about 107,000 cubic centimeters. Now let's take the cup out and measure how much liquid nitrogen we started with. What's a way that we could determine the amount of liquid that was in this cup? Well, I have a marking of the height of the liquid nitrogen on the inside of this cup. I also have some water and some graduated cylinders. So I'm going to fill this cup up to the line with water and then pour it into a graduated cylinder to measure how much we started with. Alright, so here's our final data. Our initial volume of liquid nitrogen was 135 milliliters, and the final volume of the gaseous nitrogen was about 107,000 cubic centimeters. One thing to note is that these are not the same units, or are they? It turns out that it's very, very easy to convert from cubic centimeters to milliliters, but I'll leave that for you to figure out. Using these two pieces of data, you should be able to determine how much farther apart the atoms in the gas were as compared to the atoms in the liquid. I won't give you the answer, but work with your groups to try to figure it out.